Hi everyone, welcome back to our Let's Learn office hours for the Meta Horizon Start Discord server. My name is Michelle Vo. I am a program manager here at Meta Horizon Start, and I'm here today with Xander, Tim, and Kirk from the Passthrough Camera Access API team. So before we dive into the presentation, I just kind of wanted to go over a few reminders and house rules. So for today's format, we will have a presentation followed by Q&A. These are questions that were asked in advance. So with that, I will go ahead and pass this on to Kirk.
Hi, my name is Kirk. I'm a product manager here at Meta, and I'm responsible for a few different SDKs. Amongst those are the Camera Pass-Through API, which we're really excited to talk to you guys about today. What you're seeing there in the video is one of the samples that we provide. This particular sample is using the pass-through cameras, which are the forward-facing RGB cameras, to go ahead and do object identification. And we'll talk more about that as we go forward. What you can see it doing is identifying the different cameras and then identifying the different objects, and from that putting a bounding box around them, identifying the positions, etc. But let me back up for just a second, talk a little bit about the Pass-Through Camera API itself. As I said, it allows you to access those RGB forward-facing cameras. The nice thing is that it is based upon the Android Camera 2 API. So it's very familiar, very easy to move existing apps that are using an Android camera API on other things like a mobile phone into this and take full advantage of them on the Quest. We'll go into a little more detail on the specifications, but this is limited to Quest 3 and 3S for now at least. And so we're excited to announce that we're moving into public experimental and opening that up for everyone. The primary use cases of the API are to drive MLCV models. You can think about all the exciting things you can do if you can just pick up the image that you're getting and then analyze it to provide feedback or to provide better gameplay. It can also be used for, I guess, more illustrative or graphics type of applications. For instance, you can take it to create a texture or to create lighting or to vary the lighting, add ambient color. So there's a lot of effects you can do to get your production better with it, in addition to the MLCV use case. So as I said, it's based on the Android Camera 2 API. It is going public experimental in V74. For those of you who aren't necessarily on top of every release that comes out, that's rolling out right now. It's up to about 20%, and it expects to roll out, or we expect it to roll out to 100% over the next 2 or 3 days. So by this weekend, Friday or this weekend, we'll be posting the updated docs to this and providing access. Now, the dependency is the OS itself. So you don't actually have to have the updated SDK, which is coming out a little bit later. You can go ahead and start using the samples we provided directly once they're available over the weekend. It does require a new permission. In particular, that's the Horizon OS. I know that first word looks a little goofy there, but that's Horizon OS permissions headset cameras. So you do have to specifically request it, in addition to the standard Android Camera 2 permission. We will, of course, provide sample code both in the documentation on the native side and on GitHub, and that will again be available starting this upcoming weekend. I've just provided a little snippet that's in the documentation on the native side, showing just how simple it is to create the camera manager. This code just creates it and then prints out some information with regard to the configuration. Okay, let's talk a little bit about specifications. Now, the first thing is to identify the camera itself. There are obviously two cameras, a right eye and a left eye camera. In many cases and in many of the samples, we use only a single one of these. This is because the Unity WebTexture interface limits you to a single camera, so we just take one of the cameras and feed it to it. The native application itself accesses both cameras, so you can do both simultaneously, and from that pick up a stereoscopic view or use it to create your own depth map or whatever you would like to do with it. There's two different ways to access that. If you're using the Android SDK, you would identify it by name, and that's in the first column on the left, or in the descriptor of the Android NDK, and that's in the center column. So it's really easy to identify. A few things about the specification. It is 30 frames per second. What that means is that this is, good for identifying things. It's probably not particularly good for tracking things, particularly things moving fast. So the update is about 30 frames per second. Latency is between 40 and 60 milliseconds. We're still working on that right now, but in this version, that's about where it is. GPU overhead, we've tested this, and at least in our implementation, it takes 1 to 2% of the GPU overhead when you're running it and moving the textures on the GPU side. That's not counting, the particular model that you might be running. If you're running MLCV, obviously those vary significantly, and you really need to select the right kind of model to run that fits within your particular app profile. On the CPU overhead, we're still testing. Our initial numbers on this are between 2 and 4% of total compute. What that ends up being on the app core, I'm not sure. So we're still working on that. And of course, we'll publish those numbers in more detail as we get those tested. Okay, I know this is a really busy slide with lots of text, so I apologize for that. But there's kind of two critical prefabs that are used. One is this WebCamTexture Manager prefab, for which there's a screenshot here, maybe a little bit of an eye test, but basically it just provides you the overall controller information. It obtains the permissions that you need, initializes the webcam texture. You can see in the drop down there, you can select both the resolution and which eye you want it to pick up. This is again on the Unity implementation. If you choose to implement down at the native level, then obviously you would interface there and it's a different set of APIs. But the Unity level, these are the two prefabs that we provide. The pass-through camera util, there are, as you can see here, 4 different routines that we provide as part of that. The get output sizes, which returns the resolution, the camera intrinsics, which returns focal length, principal point, resolution, and skew, the pose, and finally the screen point array. The purpose of this last one is to allow you to project into the world space and really overlay 2D type of things into that 3D space. Now we get to see a few things. In addition to the first one that we presented, this next sample is a camera viewer. So what you see it doing, when I select on it there, you'll see momentarily a white screen, then it'll grant the permissions, and you can see, it's a little bit hard to see on this screen, but that kind of center area there, if we could play that again or loop it, there we go. You can see it's taking that projection and just putting it into a camera texture and showing it in front of you. Clearly that's not very useful, but it shows you how you would do that. We've had some people use that to kind of take a snapshot to say, okay, well, let's grab an image from that and post that somewhere. Clearly you could do a variety of things with this. So that's just a simple one, how it works around my desk here at the office. Okay, so on this slide, we're going to do the camera to world projection. This is going to be a little bit harder to see, but in it, after we enable it, there's a little projection that's done, and I'll move to the side, and you should be able to see, there's the projection. You move to the side, you see the anchor points of where it is. So you can lock that projection into place, see how it's projected into that 2D space. So again, what this is trying to do is provide you the examples that you would need to take that 2D image that we're getting and project it into a three-dimensional space. Okay, this one is just trying to estimate camera brightness. So as we select this, you'll see the numbers to the right, kind of lower right, varying based upon, I'll raise my hand up and kind of cover the camera, and you'll see that number go down, and then as I remove it, you'll go back up. But what this is doing is getting an overall estimate of the brightness in the room. So it's just showing you how to use the information provided by the camera to pick that up. Okay, now this one is one I think will be very interesting for a lot of people. It shows you how to take the camera images move them in, apply them to a shader, and then have that reflect on to a particular surface. So as I'm looking down around here, what it's doing is it's taking the camera image, distorting it, and then placing it on a surface. That's really interesting for things like reflecting pools or effects that you want to create where you want to take part of whatever's in the camera image and then get that processed onto a texture. Okay, and so this one is just kind of showing our overall Sentis integration. For those of you who aren't familiar with Sentis, what Sentis does, it's a framework that's provided by Unity, and you can take any particular ML model that you want, uh, export it off of Hugging Face in a particular standard format called ONNX, compile that down, and then use it to execute within the Unity framework. So this sample shows us taking the Camera Passthrough API, moving that and driving that into that object detection algorithm, particular algorithm that's called YOLO, you only look once, that we use for this particular purpose. So we were able to do that, get it running pretty much off the shelf. Now, Sentis provides about, I think last time I looked, it was about 16 or 17 different models on their website that are already adapted for this and optimized. That's probably the right place to start. I've put that in a link down here. There are a number of qualifications to this, namely the Sentis operation. Uh, the Sentis framework only supports a subset of all the possible ML operators. And if they're not provided with a GPU-based implementation, then it moves back over to the CPU. And so you need to be careful about selecting which models you'll run and making sure that they have support in the GPU if that's where you're wanting to run it. The nice thing about this, though, is that it has kind of automatic fallback. So if the model that you're running has operators that are not supported on the GPU, then it'll run it on the CPU. It also allows you some nice capabilities in terms of slicing across frames. So in many cases, what you want to do is run a model which might be a little bit heavyweight, but you don't want to run that necessarily every frame. So what this capability does is it allows you to slice and do, for instance, a layer per frame type of thing, so that you can not impact the performance of your application, but in fact, get the capabilities you would like to get out of whatever ML model that you're loading. So I know I went through all of that really quickly. I just want to back up and kind of give you the overview again. This has been in partner experimental release for, I guess, 2 months now, and we're opening up for a public release. In a public release, it is public experimental, not public. I should be very clear on that. What that means is that you can play around with it. We will accept feedback on, hopefully improve things as if you have comments that things need to change. And what that also means is the API may change over the next couple of weeks or months until we go to public. Because of that, we do not allow you to publish to the App Store until it reaches the full public launch. We don't want apps going out there using this API and then us changing some parameter and breaking an app. So we anticipate this moving to the public release later this spring. So it's not going to be out there a long time in this stage. But right now you can use it. You can demonstrate stuff with it. You can try out stuff. You can provide us feedback, but you will not be able to publish to the app until we go full public release later this spring. So that's where we are. And now let me turn it back over to Michelle. Michelle?
Thanks so much, Kirk. So now we get to go into our favorite part, Q&A. And so with that, I'll go through each of the questions that we collected over the past couple of weeks. So question number 1, is there any performance impact in accessing the camera API?
Yeah, there is clearly a performance impact on it. I tried to put some of that into the specifications, 1 to 2% GPU overhead, still qualifying the CPU overhead. Clearly, this will vary based upon what the resolution is that you're doing. It will also vary significantly based upon which ML CV model that you would use.
Great, thank you. Question number 2, is there any kind of native QR code scanning API available to devs, whether it be QR code recognition tools built in?
So right now, as part of this API, there is not a built-in QR code library. We are working on a different API for that, which we will release in the near future.
What can we do to make users confident enough in the privacy of Camera API to allow permissions for it? This really cool feature might be useless if users decide not to enable it.
Yeah, that's a great question. To be honest, there's been a lot of debate, even going back 3 or 4 years internally on whether or not we should open this up based upon privacy concerns and things like that. So I think that, the smartest thing you can do is be perfectly transparent. And what we want everyone to be is perfectly transparent with the user about how this data is being used. To the extent that you can tell the user what your data policy is, that images won't be retained, that you're not using this to, do scanning of their, personal space for any nefarious purpose. That would be very important to put that straightforward in what your data use policy is. You are constrained in certain ways in Meta's overall data use policies. There'll be guidelines for that coming out in the release notes, but clearly we will not allow. Sorry, we we will prevent apps that are using this in inappropriate ways or ways that are not consistent with our data use policies. But going back to the original question, I think the major thing is behave responsibly as an app. Make sure you tell the users what you're doing with their information, and assure them that you're not using it for any nefarious purpose. But more than that, just don't use it for any nefarious purpose. This is probably the best advice.
Thanks, Kirk. Is there a way to easily get a portion on the pass-through image as defined by points? For example, between the controllers as a 2D image. For this person, their use case is image analysis on a defined frame in the user's environment.
Yeah, so I think it depends on exactly what you're trying to do, but I think in the camera to world thing that we showed with the example, it's going to show you how to project that space into the 3D space. So understanding what the resolution is, understand how to project that into the 3 world space, and then using standard tools for cropping or adapting that image, I think will give you what you need. We don't have object detection specifically in there to recognize the controllers. But if you know the real world space of the controllers and you can project to them, then you can pretty much get what you want out of that. Tim, would you have anything to add to that?
Yeah, so the sample that we're going to show, it's a Unity sample, but it shows you how to get the camera intrinsics and then perform there's a little bit of extra math that you need to do, but essentially you can map a pixel coordinate to, you can essentially do like a world raycast. So you can kind of it allows you to map pixels to like where that actually corresponds sort of in the physical world. But the specific question of like getting something between controllers, yeah, you could, I think, do that. You need to sort of use this utility to like get a raycast to the controller positions, and you could kind of work that out, I think.
Thanks, Tim and Kirk. Is PCA already available to try? If it's available, how do we access it?
So it's not available yet. As I said, it's rolling out in V74, which is kind of partially out right now. It'll be available the documentation will be posted somewhere on Friday or over this coming weekend. So you don't have long to wait. Unless we have some hiccup rolling out V74, you should expect the public experimental documentation of this to be posted certainly by Monday.
Can we remove play area size restrictions for mixed reality with this feature?
This
Go ahead.
particular like pass-through camera access isn't specifically related to this, but we did a few releases back introduce boundary lists for MR apps. So as long as pass-through is rendering, you can request to disable the boundary. So that is kind of a separate feature, but yes, you can do that.
Yes, I think it's already available.
Yeah, it is.
Okay, question number 7. These two are pretty similar, so I just consolidated them. Will PCA be offered through a Meta SDK and then eventually on OpenXR? Will this be available to just Unity or for our Unreal Engine too?
So as Kirk mentioned, this is actually just an implementation of the existing Android Camera 2 API. So although we have a sample that shows you how to do kind of some more sophisticated use cases, we don't actually have a specific Unity API for this. So in Unity, Unity has an API called WebCamTexture, and on Android, they use the Camera 2 API. So it just kind of works automatically out of the box. On Android, or sorry, on Unreal, you would have to do something similar. You'd have to find a way to access the Camera 2 API. I believe we haven't done anything specific again for this, for Unreal, but there are some open source plugins that kind of show you how to access the Camera 2 API. And so I think there was another question about OpenXR. Yeah, again, it's not an OpenXR API. It's basically a Java. It's an implementation of the existing kind of very standard Android Java API.
Thanks, Tim. Question number 8. Will I be able to use post-processing effects with pass-through enabled? I noticed that my scene becomes black once I have pass-through and post-processing enabled, and I assume this has to do with not having full camera access.
You can certainly take the image and pass it to a shader. Why your image is becoming black in the particular case you're referring to, I'm not familiar with. Tim, would you have any guidance on that?
Not specifically. I mean, this is kind of bleeding over into kind of a bug report. I tried this thing, it didn't work. So I'm not sure. We'd have to follow up through a forum or something. But like this is basically just a GPU texture. So any kind of shader, you should be able to interact with it in that way. It could be a lot of things going on, right? Like if this is different render pipelines than Unity, maybe incompatible shaders, it's hard to say. But yes, you should be able to treat it as just a normal texture in any shader.
Wonderful. And yes, if this is a bug, please report it through the MetaQuest developer hub. We have a new feedback hub that you can actually submit this to, and someone will support you. Next question. What is the frame rate of the Passthrough Camera Access API? Feels like this is a trivia question.
Yeah. Anybody going to the audience? No one was paying attention. It's 30 frames per second.
Great. Question number 10. Will we be able to read the intrinsics of the cameras? This is crucial for computer vision use cases.
Yes, you can. And the Unity sample shows how to do that.
Number 11. Does the pass-through we have access to have green screen masking capabilities?
Not in the sample we're providing.
Will there be any API integration for game engines like Unreal?
Right now, we're not providing the Unreal game engine bindings. We are looking at that. We haven't committed to a date for that.
Like it is possible to use it in Unreal. It's just like with Unity, we don't actually have a specific Unity API. We're just hooking up this Android API. Unity happens to use that already, so like they have an API, a standard API for that already. As far as I can tell, and I'm less of an Unreal expert, but as far as I can tell, you would probably need to look at the marketplace to get. I mean, you can still do it. You just have to invoke the right Java API.
Yeah, I guess I should be
Thanks,
more
Tim.
precise. We're just not providing samples for
Right, yeah.
Unreal. Right. This is a better way to state it.
Thank you both. Now that the RGB values will be accessible, will Meta work with Unity to integrate AR foundation features such as image and object tracking or real-time environment probes?
Yeah, we do have a close relationship with Unity, and we do talk to them about AR Foundation. The thing there is that AR Foundation does not do its own processing based on the camera image. So just having access to the camera image doesn't unlock these other features. So they would need an API from us to do things like lighting estimation or object or image tracking or whatever else. So this API is just purely about here is the RGB camera texture. What you do with that is kind of up to you. And AR Foundation can't do anything else other than surface that as a texture.
Thanks, Tim. And thank you, Kirk, Xander, and Tim for tuning in today and sharing your expertise. I know our developers love it and super appreciate it. So just thank you all. This has been super fun.